All right, so we said that we have the loop of the nephron is going to have a special function in recovery of water. And if you look at the numbers, I'm not sure that I've given them to you, but there's a huge water, 160 liters of water are filtered a day, and you produce, a couple of liters of urine at most during a day. So most of this water has to be recovered, and so what happens is we have a unique situation with regards to the permeability. That means the ability for materials to pass into or out of the loop of the nephron. And so we have the two sides to the loop of the nephron. The descending limb goes down deep towards the medulla of the kidney. Now, the deeper you go into the medulla, the higher the concentration of salts. And so the descending limb is permeable to water, but not to sodium. And the ascending limb that is coming out of the medulla, or proximity with the medulla, is not permeable to water. And so what happens is, as the filtrate, that's the plasma that was filtered from the blood, as it moves from the proximal convoluted tubule down the loop of the nephron, you have sodium that we had said was actively recovered, and we had said we have a situation where the deeper you go into the kidney towards the medulla, the more sodium there is. And so water loves sodium. Water follows sodium, and the descending limb is permeable to water. So I've drawn some water coming out because we have more and more sodium, and so water's coming out, and then you have this concentrated urine that's given up its water, and then it starts moving up the ascending limb, and the water that would now be attracted to the concentrated urine that's present in the ascending limb, because we gave up our water, so now all of those solutes that are in there would be very attractive to water, but water can't pass back into the tubule. So the what we call the countercurrent mechanism is what is going to recover water, and this occurs in the loop of the nephron. Now we have some other mechanisms for recovering of water. We had said in the endocrine system, we had talked about antidiuretic hormone. And antidiuretic hormone, we had said, in the kidney is going to introduce something called aquaporins, and this is openings that are going to be moving water out of the distal convoluted tubule. And again, we're talking about out of the tubules into the capillaries. So the distal convoluted tubule can also function in recovery of water through antidiuretic hormone, or there was another hormone called aldosterone, which is going to cause sodium to be retained and potassium to be lost. And so again, that will also increase water. So the loop of the nephron and the distal convoluted tubule are going to, in many ways, function to help recover water, because that's the largest portion of the filtrate that has been produced in these processes that are ultimately forming urine.